right, let's pick up where we left off and finish talking about the third law, Newton's third law, action reaction. So take a look at the baseball sitting on the table, right? We know that gravity is pulling it down, right? The baseball is pushing down on the desk because of gravity, or gravity is pulling it down. So what's the force? The desktop is resisting with a force that's equal but opposite, right? So they're pushing on each other and they have an equal but opposite force. And how do we know that? We know that because the ball is not changing its motion. What would happen if an elephant were lowered onto the desk? Would the elephant change its motion? Would the desk be able to push back with an opposite but equal force? Probably not. The desk would probably collapse because it could not resist with an equal but opposite force. Let's talk about gravity of the moon and the earth in terms of the action-reaction law, in terms of the third law. The earth attracts the moon, right? It pulls on the moon, and the moon attracts the earth. But did you ever think that they're actually pulling with an equal but opposite force? The reason it doesn't feel like it's an equal force is because the moon has a smaller mass. And what do we know about an object with a smaller mass being pulled with the same amount of force? What will happen to the acceleration of something with a smaller mass? Well, something with a smaller mass will accelerate faster because it's smaller if it is being pulled with the same amount of force. So the moon is smaller and it will accelerate a little bit faster than the earth because of its mass. Rockets utilize this principle. Hot gases exert a force downward and the rocket itself is pushed up with an equal but opposite force. So take a look at that. The force of the exhaust is pushing against the rocket. And the force of the rocket, let's get my cursor here. The force of the rocket, meaning the weight of the rocket, is being pulled by gravity. It's pulling down, right? And it says equal but opposite, but I believe this force of the exhaust pushing the rocket away is a little bit bigger, right? So since this force is bigger, they're unbalanced. They're not balanced. So there is a change in velocity, okay? We do have an acceleration because the force of the exhaust is greater than the force of the weight of the rocket. All right, let's review. Newton's first law of motion states that the motion of an object will change when this type of force is applied. We have unbalanced, large or small, or instantaneous. All right, and the answer is unbalanced. All right, move this a little bit closer. Because one force has to be greater than the other force in order for an object to move. Measuring inertia is really measuring what? Is it measuring time, space, mass, or distance? Inertia is really a measure of mass. Inertia is how much force it takes to change the direction of something. So if something has a greater mass, it is harder to change the direction. For instance, a baseball may have more mass than, say, a football. So if you try to catch a baseball, you need a glove because of the inertia of the baseball. What force is required to accelerate an object with a mass of 1,000 kilograms at 2 meters per second squared? So you're going to use the formula F equals ma. So mass is m times a is 2 meters per second squared. That's the acceleration. So 1,000 times 2 equals 2,000. And the units, kilogram meters per second squared, change to newtons. All right, let's take a look at the concepts we learned in physics so far and think about which of these are forces. Acceleration. Acceleration is not a force. Acceleration describes motion. Friction. Friction causes motion or causes the stopping of motion, so friction is a force. Speed. Speed describes a force. It is not describes a motion. It is not a force. Gravity is a force that pulls objects on another object with mass. Objects on the earth are pulled by the Earth's gravity. Weak nuclear is a type of force that holds the nucleus together. So yes, weak nuclear, you should write weak nuclear down. That's a force. Torsion is a twisting force. That is a contact force, so you should write that down. Tension is a pulling force, so write tension down. Inertia. Inertia describes an object and its ability to change direction. Okay, inertia just describes mass. That is not a force. Displacement. Displacement is how far an object has moved from its original position. It's describing the motion of an object. It is not a force. Magnetic is a type of field force. So yes, that's a force. And strong nuclear is a field force. So you should have written friction, gravity, weak nuclear, torsion, tension, magnetic, and strong nuclear as your list of forces. All right, normal force. You saw that on the video. What is it? Normal does not mean usual or common in physics. In physics, the term normal means perpendicular to a surface. Perpendicular means it makes a right angle or 90 degrees to the surface. When you stand upright, your weight pushes straight down. The earth resists that downward force with an equal and opposite upward force, the normal force. Or you could say whatever you're standing on, it doesn't have to be the earth, it could be the chair you're sitting on or the floor you're standing on, that object is pushing up, okay, because it's perpendicular, right? If I'm just drawing a floor with an arrow straight across, it's perpendicular, it's pushing straight up. Of course, this straight upward perpendicular is perpendicular to the ground. Let's see some here. All right. Okay, more about normal force. All right. If you're on a sloped surface, like a hill, and you are still being attracted straight down to the center of the earth, but the sloped surface is slanted when compared to the slope of the hill, what do you think the normal force is going to be? So let me see if I can draw here. There we go. I'm going to try and draw it. It's not very straight. Okay, but there we have our hill. Do you think that the normal force is going to go straight up and down like gravity? Or will it go perpendicular to the surface? Like that. There we go. All right, so that's what the normal force is going to do. It's going to be perpendicular. All right, the normal force angles so that it remains perpendicular to the ground. All right, I'm going to erase that for next time, or not. Okay, well, I'll figure out what to do. All right, so let's take a look at this object, okay? So this worker has a box of shingles on the roof, all right? And hopefully the shingles are not going to slide, right? We have force, let's take a look at the forces. The normal force is actually going to be making a 90-degree angle. If I can draw an angle, try and draw with a pen here. Let's see if we can draw a 90-degree angle with, all right, now it's not working, with the roof. There's a sliding force, okay, sliding force going down off of the roof. We have friction holding it back. Hopefully friction is greater than the sliding force or it will slide. All right. Now the normal force, we say it should be opposite of weight, but it's not exactly opposite. Okay, weight's going to push straight down. All right. So it is, but it isn't. Okay. Normal force is always perpendicular to the surface when it's on a sloped surface, it's at an angle. But think of it this way. If the roof is pushing back on the object, right, this box here, what happens if we make the roof tipped more, right? What if we start standing this up and tip it more and more and more? Well, this normal force is going to get smaller and smaller because there's going to be less pressure between this box and the roof. All right, friction. All right, friction is a contact force that opposes the movement of an object. That means the friction vector always points away from the direction of the object's movement. So if the car is going forward, friction will point backwards. There are 4 types of friction. Static means stationary. Okay, static friction was keeping that box from sliding off the roof. There's kinetic friction, sliding friction. So kinetic friction is if you were to push a box along the ground, okay, and you had to keep pushing to keep it moving, you have to keep applying a force because you're working against friction. So that's called sliding friction. If you're not just pushing a box and it just keeps going by itself, there's something stopping it, and the thing that's slowing it down is kinetic friction. Rolling friction, just tires on the ground. Fluid friction, okay, like a fish swimming through the water, okay, that was a type of drag, a type of fluid resistance. That was a type of friction. There are many factors that affect the amount of friction. If an object is moving against a surface, there will be friction. Different kinds of material create different amounts of friction. All right, so rough materials, right, they will have greater friction than smooth materials. The friction vector is always opposite in the direction to the motion. The magnitude of friction is proportional to the normal force acting on the system. So note only in the y direction which comes from. And don't worry about that part right there. Just picture the sled rocket, okay, or the rocket sled. So when we made the weight of the rocket greater, the friction increased. It went from -50 to a -100. When we increased the weight, that means we also increased the normal force, so the force pushing the snow, pushing up on the bottom of the sled, so it was sticking more, all right, because of the greater normal force. The normal force increases the amount of friction. The friction between stationary objects is greater than moving friction, so static friction is greater than kinetic friction. So what does that mean? Well, if you are trying to move a big heavy box, it takes a lot more force to get the box to start moving than it does to keep it moving. Once the box is moving, you want to keep pushing on it so it continues to slide. This means, and that's what it says, this means that it takes more force to get something moving than it does to keep it moving. All right, and here's a review question. A carpenter is standing on the angled roof of a house. What is the direction of the normal force between the carpenter and the roof? So is the normal force straight up from the ground? Is it parallel? Here, if this was a roof, would it be parallel to the roof? Would it be straight down? That sounds like gravity to me, so it's probably not that. How about perpendicular to the roof? Well, we know that normal means perpendicular, so the answer is perpendicular to the roof. All right, a carpenter standing on an angled roof of a house. What is the direction of the force of the carpenter's weight? All right, so which direction does weight always point? Okay, weight always points straight down to the ground. All right, we'll pick up with gravity next time. Your assignment is actually in your notes. So what you're going to do is take this picture. I'm going to put it back up again of an object at an angle. I want you to draw 2 pictures for me. All right, and then just draw them and then send me a picture. Okay, I want you to draw a picture of a cat sitting on a roof. Instead of a box, so draw a little cat, all right? And then I want you to draw 4 arrows. And here's what I'm looking for. 1 arrow is called sliding friction or sliding force, sorry, and that will point along the roof going down, along the hill going down. The other arrow going up the hill will be friction. And here's what I'm looking for. This is the tricky part. The weight of the cat should go straight down to the ground. Okay, it's not perpendicular to the roof. But the normal force, this arrow coming up, should be perpendicular to the slope of the roof. So it should form a 90-degree angle with the roof. All right, it should not point straight up. Let's see if I can show you what I mean. Get that pen again. It should not, I don't want to see, and I don't mean to draw this, the normal force does not go, and it won't work. I'm sorry. Maybe I can try a different writing tool real quick. Am I on laser pointer? Highlighter? You know what? Give me 1 second. Ink color was the wrong color. Let's do this color. Okay. So what you don't want to draw is a normal force that goes straight up and down. And I don't know why it won't draw it, but one more try because it gets confusing. All right, well, you'll just have to know that it doesn't go straight up and down. It goes perpendicular to the roof. Okay, so again, your quiz is draw a cat on a hill with 4 forces: the sliding force, the friction, the weight, and the normal force.